Hello and welcome to lesson 5. In our previous lessons, we looked at using the periodic table to go and visit something like chlorine 35.5 or carbon 12.01. We pointed out that these are the relative atomic masses of these elements. The relative atomic mass of an element like chlorine, Cl, with a relative atomic mass of 35.5. If you get 35.5 grams of chlorine atoms, Cl, then you get 1 mole of chlorine atoms. If you wanted to get 1 mole of Cl2, chlorine gas, then you would need to multiply 35.5, the relative atomic mass, by 2 to get 71 grams per mole, or the molecular mass of chlorine gas. 71 grams of chlorine would give you 1 mole of Cl2 gas, but 2 moles of Cl atoms. If you were to take 1 mole of Cl gas and keep it at standard ambient temperature and pressure, it would occupy 24 dm cube, which is the same as 24 liters, which is the same as 24,000 cm cube, and also the same as 24,000 milliliters, because 1 milliliter is the same as 1 cm cube. Moving in to lesson 5, we are going to develop the relationship between the number of moles of a substance, the relative atomic mass in grams per mole, or the relative molecular mass or the relative formula mass in grams per mole, and the mass in grams. So if you are provided with 5 grams of sodium, you would be able to determine how many moles you have. And to do that, you put the mass in grams here. You go to the periodic table and you get the relative atomic mass of sodium, which would be approximately 23. That goes here. Then 5 divided by 23 would give you the number of moles that you have. Those units would cancel. Here you must have grams, and then grams are going to be divided by the unit of the relative atomic or formula mass, which would be grams per mole. And because this is a division sign here, we need to change it to a multiplication and then find the reciprocal of this. Grams would cancel with grams to give us an answer in moles. But everything needs to match. This mass must be in grams. If it's given in milligrams or in kilograms, then you would need to convert your units first. Unit conversions are very important in chemistry to solve problems. So you convert to grams if needed, and then you divide by the relative formula mass or the relative atomic mass as needed. And this formula here is very important in solving advanced questions in stoichiometry. When you are given a chemical reaction, you balance the equation and you then use all of the information to predict how much of a particular substance you would get, what yield you would get. All of these concepts depend upon a mastery of this fundamental relationship here. And we don't only need to solve for n, the number of moles. We might need to solve for any one of these 3. So therefore it's useful to remember this little triangle here, where n equals m in grams, small m, divided by mr, the relative atomic or formula mass, and then you can get mass in grams by multiplying n by the relative formula mass, or you can solve for the relative formula mass by dividing mass in grams by the number of moles. But what about if you're provided with a solution, like a solution of sodium hydroxide or a solution of sodium chloride, and you are told that you have a 0.5 moles per dm cube solution of sodium chloride? What does that mean? 0.5 moles per dm cube of sodium chloride. 0.5 moles dm cube negative 3. 0.5 moles per dm cube. What does that mean? Well, 0.5 moles, we know what that is. What is 0.5 moles of sodium chloride? You go to the periodic table, you get approximately 23 for sodium and 35.5 for chlorine. That comes to a relative formula mass of 58.5. What's the unit of that? Grams per mole, because that is the relative formula mass of sodium chloride. 1 mole of sodium chloride has this mass. But if you wanted 0.5 moles of it, then 0.5 would be coming here, 58.5 would come here, and of course you would solve by multiplying 58.5 by 0.5, and you would get approximately half of this, and that comes to 29.25 grams. So if you wanted to make a 0.5 moles per dm cube solution of sodium chloride, first you will get 29.25 grams of sodium chloride. Then you would put it into a volumetric flask like this one. And then you would put some distilled water in, dissolve it, and then make it up to the mark here, which is 1 liter, 1 dm cube, or 1000 cm cube, or 1000 milliliters. That would give you 0.5 moles inside of 1 liter or 1 dm cube. This, of course, is called the volumetric flask, and it comes in different sizes. So suppose you didn't want to make 1 liter of sodium chloride because you don't want to waste your sodium chloride, 29.25 grams. Suppose you just needed 250 cm cube or 250 milliliters. Then you would get a smaller version of this bottle. And if you had a smaller version of this bottle, it means you would not be using 1 liter, you would be using 0.25 of a liter for the volume. Your concentration would be the same, whatever concentration you need. But then the number of moles that you need to put into that smaller amount of water would be different. So you would need this relationship. The concentration, which has not changed, 0.5 moles per dm cube, would go here. The volume would have to be converted to dm cube, 250 milliliters or 250 cm cube. You would shift your decimal point back 3 places to get 0.25 here. And then you're going to need 0.5 multiplied by 0.25, C here being the concentration. And then that would give you an answer of 0.125 moles. That would be the number of moles of sodium chloride that you need. But you would then have to go back to this and put 0.125 in here, put the relative formula mass of sodium chloride here, 58.5, and solve for the mass in grams. And when you do that, you would then have the amount of sodium chloride that you need to go into the smaller volumetric flask, the one that is just 250 milliliters or 250 cm cube in size.